So now we are ready to go streaming. Good. So that's the classical view of Matlab. So basically what we have here at the middle, there's a command window. And yes, Matlab is a command driven like kind of environment. If you are used to use the editor and do the scripts there, it's just fine by me. However, I will be mostly using just a command line. And then after I have done, there's also command history. So it shows every single command what I make here, also the mistakes. I will publish the command history after the show. So you can take a closer look at yourself what I did, including the errors and mistakes. Okay, on the left hand side there's the current folder view. You might actually want to go and create a directory, subdirectory for each exercise what you are making. So everything is under the document, under the folder documents Matlab, and current folder. I think you can make a subfolder here, call it exercise 1, and go there. So basically just keep track on your stuff. Okay. At the moment there's on the lower left corner there's a workspace, but it's empty since I haven't created any values. But anyways, if I create something like, wait a minute, we had some basic functions. Yes, I could, for example, create a nice set of zeros and then 1 and then 0, 0. So what I'm going to do is something like this. So we have a index vector space, that's the value, just to show so that where 0 is. So I just want to make 1, 2, 3, 4, 5. So that's the indexes, and then the values like that. So that would be unit impulse function sampled on that region of interest. Okay, so how to do that one in Matlab? We need basically both the n and then these values, but we can always just tabulate the values. I will just start with the same, that was the delta function as a vector. So I have 0, 0, 1, and then 0, 0, 0, 0, 0. So yes, so 2 zeros, then 1, then 5 zeros. Okay, and it looks like that. Then I can do the indexing. So I can do the same thing for indexes, but this would be kind of stupid way of doing, or not stupid. There's no wrong way. There's no stupid way. There are just some ways that saves energy. For example, you can use the auto indexing. So -2 to 5. Okay. So that's actually, if you have just a colon operation, then this is from 2. And with step size 1. If you do not define the third parameter there, then it's basically just from -2 to 5. And here on the workspace browser, actually you can take a closer look if you want to, but I don't know if that gives any more information. But anyways, it's a tabular view of the same thing. Okay. Now I have these, I can plot them. Right. You can use the plot, but it looks funny with the discrete time samples. You would like to stem plot it. Stem, and then okay, wait for a while, it gives you some information there. So stem xy, meaning the horizontal axis first and then the values. So horizontal axis n, the values like that. And there we go. I will dock it there so it shows up also on the stream. Okay, so yes, it looks better than what I showed on the whiteboard, but on the other hand it also looks worse. I really hate when the these numbers are touching the axis. So you might want to expand the view a little bit so to show the data, since if you have, you know, crossing lines, too many crossing lines, you start making mistakes when you're interpreting the data. So show all the data, but not at the top of the axis, unless it's totally, you know, if it must be there, then of course you leave it there. But one way to actually fiddle with the axis would be on this figure menu. All right, let me try my luck here. All right, so you can start using this kind of tool. On the other hand, my favorite, okay, let's see, let's put it back to this one. My favorite is using the command lines and just give command axis. Okay, and you give the limits. X limit minus 2.5. Remember what I told you about the decimal point. And then for 5.5, that takes care of the negative side, and then maybe the x-axis, and then the vertical axis from minus 0.1 to 1.1. All right. So that's how you scale the axis, so the data doesn't hit the axis anymore, except the x-axis, because those points were on the x-axis, but it's already looking better. And of course you need also, if you have a figure and you are doing documents, you want to also label it. X label, Y label, title. X label and then Y label. That was title. That is Y label. This is simply value, and X label would be index. Something like that. Okay, that's better. And now for documenting purpose, you can start making this document proof, and that's what you get by saving the plot as, let's see, where does it go? Print, save as, okay, there. Save as something that can be published. Okay, so when you are start doing the exercises, you will first start it by opening a template, which will be a web document at the end. So you want to use a web approved document type. So basically JPEG is fine, PNG, PGM are fine, PPN is fine. The other ones I wouldn't trust too much. I think JPEG, GIF and the portable network, anything, are web proof, the other ones are not. They are platform dependent. Especially Windows, anything which works with Windows usually doesn't work with all browsers available. I wouldn't trust that one either for web documents. So simple. I think that JPEG and GIF would be the best ones. This one doesn't have GIF. Why? It's licensed property. You have to pay if you generate GIFs. Okay, so maybe JPEG. Or actually my favorites are the portable network graphics file, because it's bitmap file and it doesn't have any artifacts. So it's basically what you see is what you get, more or less. Okay, just not that one. PNG. Oh, just call it a test1.png. And as you can see, it did something for the picture. I will just want to take a closer look. What does it look like? Exercise 1. Oh, that's nice. Very good idea to check what it actually looks like before submitting it. Okay, good. So that's fine. I have some answers there too. I'll show you how to work with the template. So on the home page, exercise 1, there's a template. When you open it, make a working copy of this one when you open it, which means you need to be logged into Google. Log into Google account and then make a basically here, very easy, make a copy, and then after making a copy you can work with it. So you can start editing it, since now it's yours. Move it in some meaningful directory, or I don't care. As long as you can share the link. Share. See, advanced properties. Anyone with the link can comment. This is how I would like you to share all of your the returns, reports. This way, there's a method for me to give feedback on every single mistake you make. Or if you don't make a mistake, sometimes I just put a comment, nice work, just to show that I actually read your document. Okay, so pay attention now. So this is the easiest way of losing 1 point. Don't share it properly. Immediately 1 point goes like that. Done. If I cannot open it first, 1 point goes away, never comes back. Then next time you share it wrong way, another point goes. Okay, so just technicalities. This is just technicalities. You really have to return it so that anyone with the link can comment. Okay, but anyways, save. Oh yes, that's a nice address, but I will use it later on. Okay, now you're ready to start working with the exercise. I'll just show you some Matlab things, but anyways, the group number. Don't worry about the group number. Actually, the most important is that let's see, maximum 3 students in one group. Work in pairs, since that's the most efficient way of working on this kind of exercises. Pairing up is a smart thing to do. Read the instructions. Basically, I go through the instructions right now, so share it properly. Okay. And otherwise, this is quite self-explanatory. There are some questions, generally 10 questions. Each of the questions are 1 point, and then you basically start answering, like create an index vector from -4 to 14. Wow, hey, wait a minute, I did something here already. Maybe that would be the right kind of comments on that one. So copy. Have you ever heard of copy paste? That will be just good answer. So they are the commands that you needed to in order to create the index vector of, but of course here this is different scale and that kind of thing. If I want a picture, then, well, this is no magic. Just insert image. Choose a file to upload. Whoa, this is somewhere. Documents, Matlab, exercise 1, test1.png. Yes, nice picture. Maybe a little bit small, so basically you might actually want to do some rescaling of stuff to just to make it say well, I can still read it. Sometimes I get so messy pictures that I have to just, you know, send it back, do it over, so that I can actually see what is happening there, but not too often. Okay, usually that's the way. In some cases, actually, I do have some links I want. For example, here, save the sound sample, but I will show you that one later on. Okay, and okay, back to this one. Just remember that I have a kind of, let me show that again. So what did we do? Just to make sure that everyone was awake. So basically, get the template of the exercise, make it your own copy, share it so that anyone with the link can comment. Done. Then start writing your names here. Okay, don't forget to write your names, since I always have nobody, some people called nobody to pass the course, and I have no idea how to mark it on the student records. Okay, so yeah, and copy paste the commands from Matlab. If there is a graph, insert the graph what you made. That's why I want those graphs as the some network approved format. Okay. And now back to Matlab window. Good. Okay, so we got our first commands, and then actually you can also generate this delta using the index function and using the definition of delta. So let's see, delta the other way. So delta n equals 1 when n equals 0, 0 otherwise. That's the definition. And we could actually just use first generated the region of interest and then just say dd equals to n equal to no test if n is equal to 0, and okay, so this would give us true false kind of array. We do casting to double. So testing if n is 0 and casting to double format. Okay, so all the calculations in Matlab actually are done in double precision. There are some limited number of things you can do on integer arithmetic, but double is the native native data type in Matlab. Okay, so that does the same thing. As you can see, nothing changed on the DD. And you still can stem it and put the axis correct there. No magic. Okay, then an example. How about if we want that the heavy side at n-1? So this is actually delayed delta. Oops, a delta. Delayed delta. So delay by 1 time step. So basically it should happen actually here. At the later time. That's why we have -1 here. The other direction would be advance. So it happened before the time point 0. So the easiest way and most recommended way would be to use the same test, say n -1 equals to 0, not equals, bigger than bigger or equals to 0, and cast that one to double. Let's see. Oh yes. Okay, so now it starts the signal at point 1. Okay. So those were the fundamental signals. Now how about the sampling? So we have, for example, x of t equals exponential. I like exponentials. Say, let's see, 0.1 times. Oh, okay. Let's make it like that. 0.001. And let's make it minus 0.001 times t. Let's see what I have to think of it. No, sorry. Let's make it just like that. T or tau. Tau is the time constant of your RC circuit. Tau equals to RC. And now just a one small interruption.